Lesson 6.11, Solving Equations by Factoring. Factoring can be used to solve equations with exponents on the variable. Equations with an exponent of 2 are known as quadratic equations. The number of the exponent tells us the maximum number of solutions the equation can have. So, for example, a quadratic equation, which has an exponent of 2, can have no solutions, 1 solution, or 2 solutions. It cannot have any more than that. Most of the time, a quadratic equation will have 2 solutions. In order to solve an equation with an exponent, one of the first techniques to use is to try to factor the expression. And this uses a special property of numbers called the zero product property. And that tells us that if x times y equals 0, then either x or y had to be 0. And in order to use this property, we have a factored form. 2x plus 4 times x minus 3 equals 0. That means one or the other of these has to be equal to 0. So what we do is we split the equation into 2 equations. Each of the factors gets set equal to 0. So I have 2x plus 4 equals 0, and I have x minus 3 equals 0. And then I solve each. I'll subtract 4 from both sides, and I have 2x is equal to negative 4. Then I will divide by 2, and I have x is equal to negative 2. And in this part, I add 3 to both sides, and I get x is equal to 3. And so see, I have 2 solutions. X is equal to negative 2 or 3. Using the zero product property, again, I have factored form already, so I split and set each part equal to 0. And then solve. So I have x minus 5 is equal to 0, x plus 7 is equal to 0. Add 5 to both sides, x is equal to 5. Subtract 7 from both sides, x is equal to negative 7. And then when I put it together, x is equal to 5 or negative 7. Here I have 3x minus 1 is equal to 0, and 4x plus 8 is equal to 0. I add 1 to both sides. 3x equals 1. Divide by 3, and since 1 does not divide by 3, I leave a fraction. Subtract 8 from both sides. 4x is equal to negative 8. Divide by 4, and I get x is equal to negative 2. So I have x is equal to 1/3 or negative 2. Here are 2 more examples, and I ran into them, so hold on 1 second and I will fix them. Okay, so what I would like you to do is I would like you to pause the video for a moment and try to work these 2 examples, and then when you're finished, unpause the video and come back and check your work. Remember to split them and set them each equal to 0 and then solve. Now that you've had time to work them out, compare your answers. If for some reason you didn't get the same answer that I got, go back and check the steps and see if you can find the mistake. Okay, sometimes our first step will be to make sure that our equation is set equal to 0. Our next step will be to factor out the GCF. Then our third step is to make sure we're factored completely, just in case. And then finally we split, set equal to 0, and solve. So our first equation is already set equal to 0. I have 6x squared minus 10x equals 0. So I want to look for my GCF. 6 and 10 will both divide by 2. X squared and x, so I can take an x. That leaves me with 3x minus 5. So 2x times 3x minus 5 is equal to 0. Now I split this. 2x is equal to 0 and 3x minus 5 is equal to 0. Divide by 2, x is 0. Add 5. 3x is equal to 5. Divide by 3, and x is equal to 5/3. So my answer is x is equal to 0 or 5/3. My next equation is not set equal to 0, so what I'm going to do is I'm going to pick this expression or this term up and move it over to the other side and change signs. So instead of having 10x squared is equal to 15x, I'll have 10x squared minus 15x is equal to 0. Now because I picked it up and moved it, it was no longer positive, it became negative. 10 and 15 will both divide by 5. They have an x in common, and that leaves me with 2x minus 3. So 5x is equal to 0, and 2x minus 3 is equal to 0. If 5x is equal to 0, that means x is equal to 0. I add 3 to both sides, I get 2x is equal to 3. Divide by 2 to get x is equal to 3/2. So my answer is x is equal to 0 or 3/2. Now here are 2 more examples. What I would like you to do again is pause the video and try these, and then come back and check your work when you're done. Unpause the video. Okay, so check your answers and see how you did. Again, if you didn't get the same answers that I did, go through and look at my steps and see if you can find your mistake. We can solve equations by factoring. So we have all of our factoring that we've done, differences of squares, factoring with and without, coefficients on the first term. So I'm going to choose my big giant X method for this one. So I need to multiply to make a positive 18, and I need to add to make a negative 9. So the things that will multiply to make 18 are 1 and 18, 2 and 9, and 3 and 6. 3 and 6 will give me a 9, and I need them to be negative. So I have x minus 3 times x minus 6 to give me a 0. I set each of these equal to 0 and solve. And to save space, I'll just put my or in between and box in my answer. Here I have a difference of squares, perfect square minus a perfect square, and if you recall, that factors as, oops, that's an n, the square root of the first plus the square root of the second times the square root of the first minus the square root of second. So I'll have n plus 8 is equal to 0 and n minus 8 is equal to 0. I'll solve each of those. N equals negative 8 and n equals positive 8. Put an or in between and box the answers. Here I have 3k squared minus 18k minus 21. Now these have a common factor in them. That's 3, so I'll factor that out. And I'm left with k squared minus 6k minus 7 is equal to 0. This 3 times this expression doesn't add anything because this is 3 times 0 equals 0. So we can just ignore that actually in this type of problem. So I need to factor the k squared minus 6k minus 7. So I need to multiply to make negative 7 and add to make negative 6. So I have negative 7 and positive 1. So k minus 7, k plus 1 is equal to 0. K minus 7 equals 0. K plus 1 equals 0. Add 7 to both sides. K equals 7. Subtract 1 from both sides. K equals negative 1. Okay, so I have 3 more problems that I would like you to try to factor and solve. If there's a GCF, factor that out first, and then factor the rest of the problem. If the GCF is a number, a constant by itself, you can ignore it at that point. If the GCF has a variable, you have to set that portion equal to 0. So why don't you go ahead and try these, pause the video, and then when you've finished, come back and check your work against mine and see how you did. Okay, check your answers and see how you did. The most complicated of the 3 problems was this one. I used my converting to factoring by grouping method. So I multiplied 15 times negative 4 to give me negative 60. 10 and negative 6 will give me negative 60 with a sum of 4. So I replaced 4b with 10b and 6b. Factored out the 5b and the 2 to give myself 5b plus 2 and 3b minus 2. Then I solved each of those. So check your work, see how you did. If you didn't get the right answer, go through and look at the steps. If you have questions, send an email. Okay, if the equation does not equal 0 and you need to factor it, we need to set it to equal to 0 first. That is absolutely important. So the first step is this. The second step is to factor out a GCF. The third step is to factor further and then split and solve. So here I have x squared is equal to 11x minus 28. So I'm going to bring this whole thing over here and change the signs. So I'll have x squared minus 11x plus 28 is equal to 0. Now I'm looking for factors of 28 that will give me a sum of 11. And that is going to be negative 7 and negative 4. I don't always have to use the x. Sometimes I can just do it in my head. So I have x minus 7 is equal to 0. X minus 4 is equal to 0. Add 7 to both sides to get x is equal to 7. Add 4 to both sides to get x is equal to 4. And those are my answers. Again, I'm going to pick this whole thing up and move it over. That'll give me 3m squared plus 16m plus 21 is equal to 0. So as long as you shift everything over, you have to change the signs. 3, 16, and 21 don't have any common factors. So I need to figure out how to factor this. So what I'm going to do is I'm actually going to come over here to the side and I'm going to say 3 times 21 is 62. And I'm going to look for factors of 62 that will give me a sum of 16. Now 3 and 21 obviously are not going to give me 16, but if I take 3 away from the 21, I end up with 9 and 7, and that will give me factors of 16. So I'll replace 16 with 9 and 7. From the first part, I can pull out a 3 and an m, and I get m plus 3. From the second part, I can pull out a 7. So I have 3m plus 7 times m plus 3 is equal to 0. Setting this equal to 0 to solve it, I subtract 7 from both sides, and I get 3m is equal to negative 7. I divide by 3, and I get m is equal to negative 7/3. And then here, I have m plus 3 equals 0. Subtract 3 from both sides to get m is equal to negative 3. So those are my two answers there. Here I'm moving the 3k over. I need to put it in between and make it positive. So 2k squared plus 3k minus 14 is equal to 0. I need to factor this. So I'm going to do 2 times negative 14, which will give me negative 28. And I'm looking for factors of 28, negative 28, sorry, that will give me a positive 3. So I have 7 and negative 4. So 2k squared minus 4k plus 7k minus 14 is equal to 0. I put the 7 with the 14 because a 2 and a 7 don't have anything in common. I can factor a 2 and a k out of the first group and get k minus 2. I can factor a 7 out of the second group and get k minus 2. So I have 2k plus 7 is equal to 0, and k minus 2 is equal to 0. Subtract 7 to get 2k is equal to negative 7, and dividing both sides by 2 would give me k is equal to negative 7/2. Add 2, and I get k is equal to 2. So again, I want you to pause the video and work these 3 problems. Remember to first set it equal to 0, then look for GCF, then factor, and then split and solve. So pause the video, and when you're finished, come back and check your work. Okay, so check your answers. Again, as it was in the last set of examples, the middle example did require the most work. However, the third example was also a little complicated, so be sure to look at the steps if you didn't get the right answers. Pause the video and go through them step by step and see if you can figure out what was done. This goes to that problem and this goes to that problem. So be sure to check your work and see how you did.